Hi, so I'm doing Unit 6, which is rates, ratios, unit rates, proportional relationships, proportions, similar figures, and scale factor. So first off, we're going to start with ratios. So a ratio is when you're comparing two numbers by using division. And that basically means like when you're comparing human to human, so or feet to feet. In the first example is yards to feet, which is considered a ratio because a rate is a ratio. But so you have to have the conversions chart to figure this out, in which I'll be handing that out to you within the paper. So if you have the conversion sheet, you would see that 1 yard equals to 1 foot. So you basically just have to check that out to see what it equals. It basically just gives you the answer straight up in the conversion sheet. So that you would write it like this: 1.3, or just 1, 2, 3. So our first example is write a ratio for 3 meters to 6 centimeters. Sorry. So you set it up like this: so 3 meters divided by 6 centimeters equals, and then to figure it out, because both of the variables are different. See here, it's meters and it's centimeters. So we have to figure out how to get one of them to be the same variable. So like one of them has to turn into meters, or the other one has to turn into centimeters. For this example, I'm going to be doing the 6 centimeters turning into meters, just because I think it's easier in this fact. So 3 meters divided by 6 centimeters. So to get to meters, you just multiply centimeters by 100. So 6, which goes to 6 times 100 equals 600 meters. So you just have to add the dot right there, so which makes it 6 meters. So then it becomes 3 meters divided by 6 meters, which equals 1/2. So that would be the answer. That would be the ratio of the problem. So right here, when you erase all of this, it just tells you the answer. So you have to convert meters to centimeters or centimeters to meters so that you could divide it to figure out what the ratio is. So that's the answer to the first problem. So another example here, we have students to students. So there are 25 students in a class, 10 are boys. Write a ratio for boys in the class. So you'd set it up like 10 divided by 25 equals what? So because it's humans to humans or students to students, you would just divide it normally because there's no conversions needed. So right now I'm going to use divided by 5. So 10 divided by 5 equals 2. And 25 divided by 5 is 5. Right, so 2/5 would be the ratio of this problem. So once again, once I erase this, it's just telling you how, because both variables are the same, then you don't have to convert the signs. In this example, it is boys to class, so you just divide it normally. So that was a simple problem. And the last problem we have is there are 66 watermelons, 33 of them are blue. So it's pretty much the same as the last problem. So you just do 66 divided by 33. So because they're, once again, watermelons to watermelons, and just because it's color, it's the same thing. So you just divide it normally, which is, so 66 divided by 33. You'd be able to use your calculator if you don't actually understand this, which is pretty wow. So 2 would be the answer. It says that right there. And if you want, you can put it over 1. So yeah, just remember to box your answer afterwards. So the next topic we're going to be talking about is rates. So a rate is when two numbers have different units. A rate is also a type of ratio. So that's like what I said earlier of how there are different types of ratios. So that's rates, unit rates, etc. So an example would be right here. A 64-ounce container of sports juice costs $6.50. A 48-ounce container of the same juice costs $4.25. Which size container is better to buy? So you would just divide this normally, like 6 divided, like right where it says it right here, $6.50 divided by 64, because it's right here, 6 divided by 64, because they're in the same type of unit. And then $4.25 divided by 48. And then that gives you the unit rate, in which it shows you which one's better. So in this case, well, the better decision to buy would be the 48-ounce container. So finding the unit rate will help determine the answer. And the unit rate is when you basically divide well, I'll be talking about that in the next section, I guess. So the first example we have is Alejandro can cook 15 potatoes in 22 minutes. How many potatoes can he cook in 90 minutes? So to set up this procedure, you have to do 15 divided by 22, and this is 15 potatoes divided by 22 minutes, and then you would still just divide that normally because it's like the same thing, and you just have to figure out the unit rate once again. So that would be 0.68 potatoes in 1 minute, and then you do 0.68 potatoes times 90, because we have to figure out how many he can do in 90 minutes, which equals to 61.2 potatoes in 90 minutes. So when you erase all of this, it just tells you that it's 0.68 potatoes per minute. Oh, I forgot to add that in. Sorry. Potatoes per minute. And then you just multiply it and you just have to write it out. So Alejandro can cook 61.2 potatoes in 90 minutes. And normally you can just round this. So it would be 60 potatoes around, depending on what they tell you to round it up to or round it down to. Alright, so your second example is there are 156 black cows and 7 black cow herders. There are 120 white cows and 5 white cow herders. Which cow has the lower cow to herder ratio? So right here, it just tells you how you have to divide 156B for black cows divided by the 7 black cow herders. So you just divide that, and that gives you 22.2. So yeah, and then 120 white cows divided by 5 white cow herders is 24. So you can see which one has the better cow to herder ratio. So the black cow herders have the lower ratio because the number is lower right here. And they also have more cows to start with. This has less cows and less herders, and this has more cows and more herders, although the black cow herders have the lower ratio. So that's how you do it. So our last example in rates is figure out the rate and find the unit rate for it. So 90 minutes divided by 5 days. So right here you can see that it's two different types of units. So minutes to days. So you'd have to figure out, like, find a way to get both numbers to have the same units or variables. So when you erase this, you see that 90 minutes divided by 5 days. So you divide that by 5 because they are both divisible by 5, which equals 18 minutes per day. So when you erase this, it shows that the rate is 18 minutes divided by 5 days. So that it already gave you the rate in the question, which is this. And then the unit rate would be 18 minutes per day. And that's how you would do rates. So the next thing we have is unit rates, right there. So this is probably the easiest type of ratio there is, because you literally just keep dividing until you get what one item costs. So a unit rate is when you divide the numerator from the denominator, and you keep dividing until you find out what one object costs or weighs. So an example would be $11 for 4 boxes. How many boxes does one box cost? So I'm just gonna give you like probably 30 seconds to figure this out. So go ahead. Okay, that was less than 30 seconds, but I think you probably got the idea. So you do 11 divided by 4 equals what? So you can't really divide that. Well, you can, but it wouldn't exactly make sense. So, oh wait, no, I messed up. Wait, no, I didn't. Okay, a rule that I forgot to add in here would be divide the denominator by itself and the numerator to find out the unit scale. So you divide 4, so you divide 11 by 4, which equals $2.75, and then you divide 4 by 4, so 4 by itself, and that equals 1 box. So you basically got the answer from dividing by itself. So it says it right there. It says it right there. So 1 box costs $2.75. Just don't forget to add that in though, because that's pretty much the answer, and don't forget to box your answer. So our first example is a kangaroo named Queenie scored 72 shots in 9 hours. How many shots did she score in 1 hour? So you do, in this one, you do 72 shots divided by 9 hours. Okay, so you do 72 divided by 9 equals, so figure that out. Okay, considering how you're probably using a calculator, I'll just put it in. So that's 8. And then, so that's 8 shots per hour. And then shots per hour. And then you do 9 divided by 9 equals 1. So the kangaroo, Queenie, scored 8 shots per hour. Just don't forget to divide the denominator by the numerator, and then divide the denominator by itself. Which you don't exactly have to do it, just divide it normally. So you'd save yourself less time. So yeah. Our next example is Tamarcus bought 275 watermelons in 5 hours. Find the unit rate. So it's the exact same thing as the first one. Like I said, unit rates are the easiest type of ratio there is. So you do 275 W for watermelons divided by 5 hours, which 4 hours. And then you do 275 divided by 5, which equals 55. And then 5 divided by 5 equals 1. So that leaves us with Tamarcus bought 55 watermelons per hour. So then you just write it out. So Tamarcus bought 55, it's too close together, 55 watermelons per hour. And then just box your answer or write it. So 55 W per hour. Yeah. And then our final example for unit rates is this one. So Lavitrius had 327 songs in her album. 18 songs cost $36. How much does one song cost? So you would just do $36 divided by 18 songs, so S for songs, which equals, well, divide that out. Okay, $2 per song, or 2 divided by 1 if you want to do that, because it's 36 divided by 18. So, continuing on, adding on to this question, it's how much do all the songs cost combined? So you would have to do 2 times 3, why did I do that? Okay. Oh yeah, 2 times 327 equals 654 songs combined. And I did 2 times 327 because one song costs $2. It's a messed up dollar sign. Right? So because that is the unit rate, you multiply that by the amount of songs, which is 327, and then you get the answer, which is 654. So in this one you have 2 answers, which is $2 for the unit rate and $654 for all the songs combined. Alright, so the next topic we're going to be talking about is proportional relationships. Yeah. So a proportional relationship is when the ratio or rate numbers are at a constant pace. That might not make sense at the moment, but once I show you how to do it, then it'll be much easier. So the rules are, if the number was 3, then it would have to continue adding 3 to the next numbers, so that it could be proportional. If it doesn't move at the constant pace, then that means it is unproportional. So here's an example. So it starts out with 9, and then it keeps going, so like plus 9, plus 9, plus 9, plus 9, plus 9, and plus 9. And then this is just plus 1 each time. So because the number starts out with 9, and then you keep adding 9, that just proves that it's proportional already, because 9 plus 9 equals 18, 18 plus 9 equals 27, and it goes on. So the number of songs the number of songs is at a constant pace, and so is the cost of the item. And to check, if you want to test if it's correct or proportional or not, you just do 1 divided by 9 equals 1 divided by 9, and then you just keep going. So like 2 divided by 18 equals 1 divided by 9. Wait, I should probably like put this sign instead to show that it's separate. And then you could just pick any, so like 7 divided by 63 equals 1 divided by 9. So all of them equal 1 divided by 9. But you could also use cross multiplication to do it. So like the arrows show right here, 1 times 18 equals 18. 2 times 9 equals 18. So these two are proportional. 3 times 36 equals 108, and 4 times 27 equals 108. So that's also proportional. 5 times 54 equals 270, and 6 times 45 is 270. That's proportional. And then 6 times 63 is 378, and 7 times 54 is 378. So that just shows that this equation is proportional. So just write out if it's proportional or not, and then show your answer. Oh, that's a bad square. Right there. Okay. So our second proportion or example is 9 divided by 5 equals 36 divided by 20. Okay, so you can also use cross multiplication to figure out if it's proportional or not, like I said in the last equation. So you would have to do, if you want to do cross multiplication, you do 9 times 20. 9 times 20, which equals 180. And then you do 5 times 36, which also equals 180. Let me just fix my 5. Okay, so 180 equals 180, which means this problem is proportional. So you can see that proportional relationships are pretty much connected to proportions, but they're a little different. So let's see the last problem. Determine if the tissues are proportional to the amount of boxes. So the number, well, this, a hint to show that what the answer would be, if it's proportional or not, will be right here, like I showed you in the first one. So the number is 60, except you're adding 30. So that's kind of a hint that it is not proportional, because you have to continue adding 60 to the equation to show that it is proportional, and this is adding 30. So just a really big hint right there that is not proportional. So you could also, to check if you want to, you do 1 divided by 60, which equals 1 divided by 60. And then you do 2 divided by 90, which equals 1 divided by 45. And right there is where it shows that this problem is unproportional, because in the first one that I showed you guys, the first problem, I showed you that the first two are equal to each other, or they're all equal to each other, and this is not. And then you could also try out the cross multiplication problem. So 1 times 90 equals 90, and 2 times 60 does not equal 90, because 2 times 60 equals 120. So that equation is unproportional. Yeah. Okay, so the next set we're going to do is proportions. So a proportion is when two ratios or rates are equal, either when simplifying or just generally. So you can use the multiplication property of equality to help answer some questions. The multiplication property of equality is if two numbers are equal to each other, then it would continue to be if you multiply a number on both sides. So A equals B, so 2 times A equals 2 times B. and that would still be proportional because you're adding 2 on both sides, so making it still equal and proportional. So, is 18 divided by 9 equal to 14 divided by 7? To figure this out, you would just answer the problem. So 18 divided by 9 equals 2 divided by 1, is basically just 2. And then 14, which equals 14 divided by 7, which equals 2 over 1. And that is proportional because they are both 2 over 1. And if you want to check, again, by using the multiplication property of equality, you do, well, for another example, I mean, I messed up. Okay, one sec. Oh, right here, sorry. That was my bad. So you can multiply 2 times 4 to the equation. So you do 4 divided by 2 times 2 times 4. So you add both of these together onto the equation, which equals 8 divided by 4 times 2 times 4. So both the 2's would cancel out, and both the 4's would cancel out, leaving 4 times 4 and 8 times 2. So 4 times 4 equals 16, and 8 times 2 also equals 16, meaning that this is a proportional relationship. So yes, proportional. So just remember that if there's these two numbers, like a 2 and a 2, they can cancel out, and then you just multiply them together. So that's how you do this one. Our last example is using a variable, so not a number, which is t. And you could do the exact same thing, and it'd be easier to just do the multiplication property of equality. So we do 8 divided by 4 equals t divided by 8. And then you do 8 times 8, which equals t times 8. And then you do 64, because 8 times 8 equals 64, which equals 4t. And then you do, let me just rewrite it right here, because there's more space. So then you do 64 equals 4t, and then you divide 4 from both sides so you can get t by itself, which equals 16 equals t, and then just like flip the signs, flip it to be that. So that would be the answer. But this isn't using the multiplication property of equality. This is just using cross multiplication to figure it out. So cross multiplication is a big deal with rates and ratios in Unit 6. So yeah. Alright, so the next thing we're doing is scale drawings. So a scale drawing is when you dilate an actual object to put it on paper, to fit it on paper. A scale model is when it is an actual figure that is dilated so that it can be a specific size. So the rules are the length and width of the scale drawing or model have to be proportional towards the actual object. So if they aren't proportional to the actual object, then you would just have a messed up figure and it wouldn't be correct. And it would be unproportional. So our first example is, let me just read it. Chang knows the distance to her grandmother's house is 21 miles. On a map, the distance is 5.25 inches. What is the scale of the map? So I'm going to give you a few few seconds to just process that and try to figure out how you would fit it in and figure it out. So go ahead. Okay, so you have to use units to figure out this. So don't forget to put your units, because if you don't put in your units, then the answer would be wrong. So 5.25 inches divided by 21 miles. So you just divide that normally. So 5.25 inches divided by 21. So let's use this. 5.25 divided by 21, which equals 0.25. So that's 0.25 inches per mile. So that is what the scale of the map is. So just write that in. So the scale of the map is 0.25 inch per mile. And then to check, you would just do 5.25 times 0.25, and then let's just figure that out again. So 5.25 times 0.25, which equals well, this is embarrassing. Wait, no. Oh wait, no, I messed up. It's 21 times 0.25, which equals 5.25. That's why. Okay, yeah. No, don't do this part. Do 21 times 0.25, which equals 5.25. That's why. So then you would just box your answer, which is this. You can box it in the word answer or just normally. So that's basically how you do similar scale drawings. And then just don't mess up scale drawings with a scale model, because a scale model is when it is an actual figure that is dilated so that it can be a specific size. So that's the difference between a scale drawing and a scale model. So that's how you do it. And then another example could be if you want to add like two different types of units. This isn't on the PowerPoint, but I'll just scroll down and do it. So right here, here. So you do 1 inch. So like let x represent the actual distance, and then write and solve a proportion. So let's just make up a problem right now. So a map shows a scale of 1 inch, which equals 6 miles. The distance between two places on the map is 4.25 inch. That's a bad W. What is the actual distance? So that's a word problem that could pop up on the exam. And where'd it go? To figure this out, you do 1 inch, which is the map width, and then divided by 6 miles, which is the actual width. Which equals 4.2 inches, 25 inches, sorry, which is the map width again, divided by x miles, because that's what's missing. So the actual width. Where is it? Actual width. So you'd have to do cross multiplication to figure this out. So 1 times x equals 6.6 times where is it? 6 times 4.25. So that is just 1x, and that would be 25.5. So x equals 25.5. And then you just simplify it, which would be that. So this is the answer. Okay, going back up. So now we're just going to go down to similar figures. So similar figures is when two geometrical objects are both the same shape but with different sizes. So similar to scale drawing rules, just use the multiplication and division. And then, okay, let's see, where'd my mouse go? It's gone. Technical difficulties right now. This is embarrassing. Okay. Well, I have the paper right in front of me, so I can just read it out while this is still trying to work. Okay, so it says, Rio drew 2 similar rectangles. One rectangle was 9 inches long and 6 inches wide. The second rectangle was 15 inches wide. How long was the second rectangle? So this is pretty visual. Where is my mouse? I'm gonna try using this. Okay, Alejandro drew that. Okay. So hopefully my mouse will work now. No? Okay. I guess I'll just draw it. Wait. Oh, that's why. Okay. Yeah, got it. Okay, so you draw the first square, which would be, you draw 6 over 9, and then you do the bigger box. Let's just draw that bigger. 15 by x, and then you do 15 divided by 6 equals x divided by 9. So that is, why is it zooming in? This is once again technical difficulties, I guess. Keep saying, okay, my computer's messing up right now. I'm not doing anything. I'm not sure what's happening. Okay, so 15 times 9, which is 135. Yeah, 135. And then 6 times x, which equals 6x. So you divide that by 6, both of them. And then you do 100, and so this cancels out, which leaving 135 divided by 6, which equals to wait, let me just check this out. 135 divided by 6, which equals 22.5. 22.5, and that is x. So then you just plug it in. So you erase x and you put 22.5. And that is the answer. So our next problem is, my mouse is messing up again. I'm not sure what's happening. Alright, so the next problem is find the value of x in the similar polygons below. So that is, you basically do the same thing as what happened in the top. So we did 15 divided by 6 and x divided by 9. So right here we get 18 divided by x, and if you keep forgetting, then just go back up and see what's up. It kind of rhymed. And then you do 4.5 divided by 1.5. Then you just cross multiply. So 18 times 1.5, let's make that more visual, equals, let me calculate that, so 18 times 1.5 equals 27, and then x times 4.5 equals 4.5x, and then you do 27 equals 4.5x, and then you divide it, which equals 27 divided by 4.5 is 6. So x equals 6. And once again, you just plug that in. So just cross that out and put 6 feet. Okay. And then our last problem is polygons. Find the x. And you literally just do the exact same thing as the last two problems, except now it's just a little different because it's a triangle, but it's the same thing. So 4 divided by 4 yards divided by x yards, which equals 1 yard divided by 0.66 yards. We do cross multiplication again, so 4 times 0.66, which equals 4 times 0.66, 2.64, and then 1 times x equals x, pretty much, 1x if you want to do that. So then that equals 2.64 equals 1x, and then you divide it. So if you honestly can't figure that out, then divide it just to double check, and that's the same thing. So x equals 2.64 yards. Alright, so that's the end of my video presentation. Thanks for watching. Goodbye.